Hello guys, my name is Amit and I'll be the instructor for this course, Machine Learning with Python. Let me introduce you to this course and we will see what are the different topics we are going to cover. We are going to start with the very first module, setting up the environment. Because this is Machine Learning with Python, we have to have Python installed on your machine. We are going to use Python 3.x series. To write the program, we are going to use the free PyCharms Community Edition. We need different packages like NumPy, Pandas, SciPy, maybe Matplotlib, PyTorch, Keras, and bunch of other packages to run our application. Once the machine is configured, we'll start loading the dataset from different sources like the CSV files, Excel files, databases like MySQL, MongoDB, or we are going to directly load the data from different URLs. In this module, we are going to see how to load the data. Importantly, we are going to learn the data. We'll see insights of the data. We are going to clean the data and we'll start getting the text summary of the data. We are going to use the techniques like how to get the different statistics of the data. We are going to get the data dimensions. We are going to see the different class distributions. We'll see how the attributes are correlated, and we'll see how univariate skew affects your data. Once the data is loaded, we are going to start going for the visualization. The data visualization is the stage where we'll start getting insights of the data usually by using different libraries like Matplotlib and the Seaborn. These libraries will help us to draw different graphs or to create different plots like univariate and multivariate. Now once the data visualization is over, once we understand the data, we'll start preparing the model. But we can't prepare the model unless we know the right columns, the right selection of the columns. The columns are called as the features, and we are going to select them by using different techniques. We can either select them manually by looking at the data, or we can use different techniques like PCA, LDA, or feature importance, recursive feature elimination, and univariate selection. Once the features are selected, we are going to start building the model where we need the different algorithms. The algorithms like non-linear and the linear regressions. For example, we are going to use the simple linear, multiple linear, logistic linear, like the linear regressions, and k-nearest, maybe naive Bayes, card trees, and SVM, like non-linear regressions. Once we start getting the algorithms, we'll start getting the result. But how would we choose one algorithm over the other? That will be decided by using the next module, where we'll evaluate the model by using different techniques like the train sets test split, maybe the k-fold cross validation, maybe a repeat random test train split, and stuff like that. Now once we start getting the evaluation matrix, we'll start getting the accuracy, logarithmic loss, area under ROC curve, confusion matrix, classification report, regression matrix, mean square error, and mean absolute error. With these criteria, we are going to understand how well our model is behaving. What is the accuracy of your model? And based on that, we can decide whether to go with this model or whether to improve the model. Now, sometimes it is required to improve the accuracy. How will you improve it? To improve the accuracy, you might combine different algorithms together with a technique called as ensemble learning. Ensemble learning is where we are going to get the different models, combine them together, and we'll get the final accuracy. There are a couple of different techniques like the bagging, boosting, and stacking, which will help us to improve the accuracy. We are going to learn the decision tree, a random forest, like the bagging technique, and add a boost, gradient boost, and the extreme gradient boost, XG boost, like boosting techniques. Now, sometimes you might see the data is huge and it is not possible to process it on your machine. So where we are going to put that under different nodes by creating artificial neural network. This is generally called as a deep learning, and we are going to understand the deep learning from different perspectives like ANN, RNN, and CNN. The ANN will be the artificial neural network, will be the base for RNN and the CNN. RNN stands for recurrent neural network, can be used for NLP-like applications, and CNN, convolutional neural network, we are going to use it for image classification. We'll see whether the given picture is of cat or dog. This kind of problems can be solved by using CNN. So there are different techniques we are going to see in this model. Now once we start calling those algorithms, we are calling those functions, we need to pass different parameters. Now once we start passing the parameters, we'll start getting the result. But how would we know what is the best value for that parameter? This technique, parameter tuning, will decide what is the best value for it by using different techniques like the grid search or the random search parameter. So here we'll start getting all those different stages combining into one single pipeline. When I say pipeline, this will be considered as one single project, one single unit, which will have data preparation, feature selection, modeling, model evaluation, and getting the final result out of the entire pipeline. Once the pipeline is done, we will start getting the result by passing the actual data inside it. Now, sometimes you want that model to be available to the other users than your local machine. So we are going to use a library like Pickle or Joblet to save our model into the file, and we'll finally deploy it onto the cloud environment like AWS, which will be accessible for most of the users around the world. This is what we are going to cover under this particular class, machine learning with Python. So best wishes for your learning, and hopefully I'll see you soon in the course. Thank you very much.